much more complex because it performs not just one type of radioactive decay, but two types of radioactive decay, or maybe even three, so that the waste product is processed into another usable fuel, which is a parallel energy source in a separate type of nuclear decay reaction. Yeah.
Vitrification.
Vitrification. Like vidrio in Spanish means to glassify. And you can actually use a bunch of sand, which is high in silica, to encapsulate waste in a giant molten glob of glass. It's like a jello mold with a banana in the middle. If you put nuclear waste in a huge glob of fancy glass, you can make glass that blocks radiation. So it's a way to encapsulate waste. It takes a lot of energy, but it is actually like a pretty darn safe way to deal with your waste. Everybody look at Ben right now. Oh, Ben. You don't want everybody else to say, is that just for me? No. Okay. Other vocab I can help you with? There is no other vocab I can help you with? Last call for 7.5 vocab. All right, great. The very first thing we need to discuss in nuclear power is this concept of enrichment. And in order to understand enrichment, we have to discuss isotopes. And in order to discuss isotopes, we have to discuss the Bohr atomic model. So this is one of those chemistry band-aids for the rest of you. Okay? Thank you, Ben. That's really helpful. Ben, are you ditching another class and then
he's gone?
He ditched yours as well.
Okay. Everybody knows Ben Collinson? Yeah. If you see him out in the street, hit him with your car. Just kidding. Poor Ben. Now I'm fired too. Okay. If I'm fired, I've got nothing to lose.
Well, then you're not wearing your little.
Uh-oh. Dang. I mean, that's evidence. Oh, dang. No joke. No joke. Thank you. That's the first time I forgot that. Okay. So look, we have video evidence. Okay. Remember that protons have a positive charge. Neutrons have no charge. They are neutral. This is called the nucleus. And in chemistry for babies class, we say that the electrons spin around the nucleus in rings, while in a chemistry for grown-ups class, we say that the electrons technically fly in clouds of probability, which are shaped like a figure eight. Either way. What's that?
Yes.
Does that mean what?
No, they got it. uncertainty principle.
Generally speaking, the number of protons is proportional to the number of neutrons, which is proportional to the number of electrons, especially at roughly room temperature and especially for the smaller atoms. As our elements get bigger, meaning toward the bottom of the periodic table, that ratio starts to break down. And coincidentally, some things like hydrogen lack a neutron altogether, while some things like have a whole lot of extra pieces tacked on inside that nucleus. Which one? Union, yes. And unilium?
Those names, I think there's two other names now.
And by the way, we've added some since this was built. We filled in a couple over here, and I think one on a row down.
California.
No row down? No row down.
California was the
Okay. I'm sorry, but I need to continue. Excuse me, but I still need to continue. This is where some of my students start to get some confusion with the concept of isotopes. Isotopes, if somebody wants to help me, it's my first time explaining this. You can see I'm adding material to the board. You know, I'll get better at this by the end of tomorrow when I tell all the other periods, but I'll be an explanation for an isotope, a different version of an element.
Yeah,
it's like the number of protons like defines what the atom is and like its properties to a great extent. So you can change the number of neutrons that are attached to any atom's nucleus and not change what element it is, so that's defined by the number of protons. And you don't change the charge because neutrons have a neutral charge. So it just becomes the same atom, but it's heavier because it has more stuff.
Exactly. Remember, neutrons do not have an electric charge. Yes?
Is it like uranium 3? I'm making up a number like 358.
283, 284, 285? Yes.
Oh, okay.
Yes.
So, okay.
Yes. Now, an isotope is a version of the atom. For any given element, the element is dictated by the number of protons. The element is based on the number of protons, but you can add or remove neutrons, which changes the weight. Not its charge and thus not its bonding properties. Is the bell about to ring?
Yes.
How close?
3 minutes.
Okay. One thing that I need to clarify. How many of you understand what I'm talking about, and this is totally underneath your feet, but chemistry was like so 1984. And then how many of you need me to clarify more because you don't have the chemistry information for this? That's fine. Okay.
Oh, wait.
It's all good, so give me just a moment. Isotopes are either heavy or light. They have variation in the number of neutrons. That doesn't change the number of electrons or protons, which means the charge is the same, and electrons and protons affect the behavior of atoms relative to each other. We'll come back to talk about what this means tomorrow.